Today, I'm having a conversation with Aleh Kandrashou, the co-founder and CEO of Cuby Technologies. I first met Oleg and came across Cuby when they were looking to build one of their first factories in my hometown of Detroit. Cuby is building micro factories for new home construction. These compact automated facilities are placed near home construction sites, and they produce different components of a home pretty much on demand. Now, what's interesting about Cuby, which is very different than many other companies in the space, is they have reimagined the home building process from the ground up. Not just the construction, but the entire supply chain and logistics around building a home. Cuby is the exact type of innovation around decentralized production that we like to explore here at Going Direct. And Oleg himself is a fascinating guest. He's originally from Belarus, and he's often described as an engineer's engineer. He has dissected every step of the home building process and reimagined it from first principles. Today, we dive into his journey, the technology behind Cuby, and the future of decentralized home construction. It's a super interesting and thoughtful discussion. I hope you enjoy it. And in full disclosure, I am an investor in Cuby because I believe so much in what they're doing and their approach to solving the problem around our skilled labor shortage and a lack of quality, affordable housing in the US. I hope you enjoy, and remember to go direct. I'm here with Aleh Kandrashou, the co-founder and CEO of Cuby. And just before we hop into it, just for full disclosure, I am an investor in Cuby. That's how I originally met the team. But super excited to talk to him today about who he is and what he's doing. And it'll be a wide-ranging conversation, I'm sure, around all things decentralized production. So, Aleh, give us a quick little background and kind of who you are and what brought you to Cuby, basically.
Well, I have a physicist background. I'm an engineer. I set up a bunch of manufacturing companies myself. And the biggest of them is called Incata. It's 200 plus hardware outsourcing company who help deep tech startups to grow from idea to mass production. That's why we take the scientist who almost finished his development, and with my engineers and machines, we produce prototypes, do all the drawings and documentation, and start mass manufacturing. That's why we was like a bridge between science and life. And 5 years ago, we made a decision to build our own headquarters and begin to communicate with the construction industry. And I understand that the industry in comparison with manufacturing is totally dysfunctional. And I understand that our expertise in setting up the factories and to do big projects in designing, engineering, and so on can help to change something in the industry. And that's why we started the Cuby technology, because we understand that we don't want to spend money in some obsolete project that can predict, because, the same project can do, the same teams can do the same project and the result can be different, And the same situation roughly was in automotive industry in the last century, where there were a lot of design bureaus. All of them produced different type of cars, but the price was so high and the result was not predictable. And the Henry Ford made the standardization of all the process, make the conveyor, and right now we can use cars with reasonable price and good quality. And we almost did the same, but in more complicated construction industry. We have more dimensions than the Ford had.
Okay, so if we step back, so kind of the background being in basic outsourcing. Give us a little bit more in the background, because then we'll talk a lot about Cuby.
I have physicist background. I have PhD in economy. I wrote a book, how to create the engineering team and how to operate them. And as I told you that all my life, I start mass manufacturing and start doing designing and manufacturing. This is my general background.
Got it. And so where did you grow up?
Well, in Minsk, in Belarus.
In Belarus, okay. And
I spent a lot of time in different places. My father was a military man, and that's why we relocate from one base to another. That's why my childhood was very interesting.
Cool. Where did you move around to? Give us a few places.
Yeah, we live in Germany. We live in Ukraine, in Kazakhstan, in Belarus, and all over the world.
Got it. Great. And so, so tell me, what was your biggest learning? You spent 10, 15 years spinning up engineering teams and helping folks go from kind of like design to kind of mass manufacturing. And like, what was, before getting into construction and everything, what was the biggest problem that you saw through that work?
do you know that the construction, it's everything related logistic. If you will solve the logistic problem in the construction, you will solve the construction at all, because it's a tons of materials that you need to use every day. And the same stuff in manufacturing. And one of the main learnings that I have now, it's a lean manufacturing approach. It's a Toyota production system, how it's work, how to operate and manage people, materials, and information. And based on these principles, based on this experience that we have, we set up the...
Okay, so because most people will be like, hey, I just need to improve. I just need to bring multiple technologies together to make it more efficient, to have this lean manufacturing process. But I think what is interesting, as you said, that's actually not the problem. It's actually a logistics problem and a materials problem. So yeah, that's like, is that, and do you find that, is that kind of a common thing that you find across different industries that you've worked in, or is that just specifically construction?
It's specifically construction because, let's say, for example, each factory, Cuby factory, consume 3 ship containers a day. That's why you need to set up the process in that manner where you need to consume these 3 ship containers. You need to reload it, unload it. You need to have some standard parts that you need to take. You need to have some parts to assemble it and so on. That's why everything that we're doing solving the logistic problem in software, in assembling process, in manufacturing process, and in machines. And all of them tie to each other. But to make a long story short,
Sure.
Yeah, do you know that everything is regarding logistic? If, for example, we will do something that will solve the logistics starting from the factories that use materials and ending when we assemble it, it will be done. Cuby will not need in this case, but it's impossible to do it in this way.
So tell me about that, because it's interesting to me. I actually have a fair amount of experience in the world of real estate development, spent over a decade doing that in Detroit. And so you're speaking my language a little bit, understanding the challenges, both with home building and also commercial building. But you mentioned multiple things, right? Software, hardware, machines, materials. And so when you looked at the problem, were you like, hey, we have to rip this down to basically almost re-engineer the entire process, step one, and do the entire stack? Is that kind of where you came out at it?
Yeah, something like that. I would try to explain. Let's say, for example, we will take the standard construction. And in standard construction, the guy make the installation of the window, let's say, how the processes look like. He measured, the hole in the wall, how to do that. He sent the information to the manufacturing, what size of the window it should be, send the request, pay the money, they produce it, they send it back, they take this window, take some tools or something just to lift it and put it inside the hole. After that, he screw it, or maybe produce some parts to screw it, and so on. I explained to you a lot of some operation that the standard guy doing. And it's taking him roughly 100 hours to do that. Let's say that the manufacturing produce windows with that exact size, and the wall is already pre-produced for this size. And on the construction side, the guy have a special tools like a sucking systems that take it, for example, and put it there. And all the fixing equipment is already installed on the wall, on the window. That for the construction worker, it will take 1 hour.
Okay,
that's just easy stuff.
Sure.
And in this case, in the first case, the same result, but he spent 100 hours plus a lot of mistakes redoing the window if they will make a mistake in sizes or something like that. In the second case that I explained to you, he do it in 1 hour without any problem. And to do it, you need to have special tools. You need to have a special software that control the sizes, to give the task to the exact workers what they need to do, how to do that. Plus, you need to have some tools. Plus, on a factory, you need to have a machine that produce windows with exact size and exact parts. And you need also to design window and all the fixing parts that you need to have. It sounds easy, but to do that, to make in 1 hour, you need to spend a lot of engineering hours to do all of this process and to tie. That's why As I told you that we use machines, we use software, we use, logistic stuff, how to deliver it and so on. When you think about all the process in the line.
Just this will maybe be helpful for the listeners. So can you give me a quick 1 or 2 cents of what Cuby's actually building, like in a way? And then I want to come back to this, why we're stuck in the I don't know.
Well, initially,
we're stuck in some age that's not efficient at all. That's for sure in the world of building and construction. So
the Cuby produce factories that produce homes.
Okay.
And that's why the factories turnkey solutions that starting only raw material in the beginning and assembled houses at the end. That's why we're not some intermediary between general contractor and material manufacturing or developer, something like that. The factory do everything inside the factory and assemble it. That's why assembling, it's a part of the conveyor. That's why it's a factory that produce installed homes. This is what the Cuby is doing. And our main, idea is by the providing mobile microfactory to give access to the people for affordable, good quality houses. This is our goals we're planning to do next, 50 years.
Gotcha. So the idea being, I believe you call them the micro mobile factories, right? So the idea is building factories much closer to where they're built. And there's a factory within the factory that's making all the parts of the house, right?
Yeah. That's why, the factory consume raw material, produce some kit of parts like a Lego parts based on the stages, that assembling stages, and deliver it in the packs on the construction site. We're assembling workers on the construction site using this kit of parts stage by stage, assemble the house starting from the ground and ending for the interior and exterior finish.
Got it. So let's go back now. Let's go back to why is construction and home building specifically, from your opinion, like why is it? It seems just like stuck in such this archaic way. Like what is your view on that?
Do you mean why the construction is a logistic problem?
Well, you kind of explain this concept. Let's just take a window, for example, right? You get a window or a wall design for a window, and there's back and forth, and there's all these different components, super inefficient, very labor intensive to install that window. Versus if you rip that down from the very beginning and you design all the pieces together, you create a bunch of efficiencies. And so that was just one perfect example, I think, of like how you see the world of construction working today.
Not only. There is two differences between manufacturing process and a construction process. The construction process, it's a project management system where there is one or two guys who control all the process, all the, subcontractors and so on, like a waterfall. And if something will happen, all the project will fall down. Because if for example, subcontractor will not supply windows just in time, they're waiting for 2 days or 20 days or something like that, and they can do, work further. This is a standard project management work. Is the same as a software development. When you develop the software, you're doing the same stuff. So there is a project manager who control everything and so on. Manufacturing, it's a different process. Manufacturing, it's a line, conveyor belt. When one process controls the previous one, that's why the system is controlled itself. And based on that, you can predict all the problem and you can control it easy. But to do that, you need to think about this process and you need to spend a lot of time to think about all the process in the line. In the manufacturing, when you have a physical conveyor belt, it's easy to do. But when in the construction, you have informational flow, informational conveyor belt, and it's distributed in different places, plus you have a tons of different materials and raw materials, it's very complicated to do such kind of manufacturing from the construction. And we did that. But to do that, we share the construction process on 35 stages. Each stages we share on tasks. Each task we share on some entity, we call it quant. Quant, this is some kind of entity, I don't know how to say it. At the same time, it's a cost of material, cost of labor, cost of tools, and instruction. And that's why all the process of construction we are calculating, I'm a physicist, as a quant. That's why we're doing the quant system of the construction. And when we do this standardization of very simple operation of assembly, simple operation of construction, based on that, we begin to make the conveyor. And based on that, we begin conveyor of information and conveyor of materials. Sorry, it's maybe very complicated, but I try to explain it as easy as possible.
No, I want to dig into it, because I think what you're getting, to me, it's like, that's what I want to dig into, I guess, is my point. So if I understand it correctly, you're kind of saying there's kind of two systems here. You have the construction side, which is really just a project management problem or process.
Yeah, exactly.
And then you have the manufacturing side, which we discussed, which is like, obviously it's a manufacturing process. These are two very different things. And kind of what you're saying is you kind of have to integrate these two.
We integrate them, and we construction process we make as a manufacturing in the conveyor in information and supply the materials. And to do that, we come up with a system how to calculate all of that stuff based on the quants. And quant, it's very simple stuff that understand any unskilled labor. I will explain to you what type of quant, for example. Let's say you have a stage of foundation. In the foundation, we do two types of foundation. It's helical piers and it's concrete slab. In the helical piers, we have one quant. It's one helical pier, one. In this quant, we calculate how much material we spend. We have instruction how to screw it. We have how much materials, how much parts we need to use it. And we have a software that control the coordinate of each quant where you need to screw it. Based on that, unskilled labor on the software have a task. You need to screw the pile. Open it. He sees the instruction, pass through the test. Now he know how to do that. Push the button and the system show him where he need to screw it. When he do it, he pushes the button that he did it, and the system automatically calculate him how much salary we need to pay for them when he will do this quant. And that's why, based on these quants, we calculate all the construction and we give the task to the manufacturing what they need to do just in time.
Okay, lots to unpack there. So the first reaction, I would say, is you hear, I'm sure most people ask you this, is you hear the concept of modular housing, right? That was the whole idea, right? Create parts to build a house, ship those parts, and build a house much cheaper, and largely have been unsuccessful in saying what you said, which is addressing how do we deliver quality housing at an affordable price with the labor shortage that we have. So can you just walk me through a little bit about kind of how your approach is different than kind of all these other modular housing approaches?
Well, there is two types of modular. One of them, it's modular itself, when produce the boxes, and the boxes is ship it and deliver it and stack it one-on-one. They're doing the same construction, but do it under the roof. But for sure, if they would do it under the roof, they save some time and some materials because they control it on roof in the manufacturing, and that's why it's easy to produce. The second type of modular, it's prefabricated, when you prefabricated parts like us. In this case, to design prefabrication, it's very more complicated because you need to do the design, architectural design every time when you come up new type of house. In our case, we do design automatically when we put the draw plans in our software, and the system automatically generate all this kit of parts and give the task to the manufacturer what they need to do. And one of the main difference that we have, there is a KPI in modular manufacturing. It's called MRL, Manufacturing Readiness Level. It means that how much percentage you spend on a construction site in comparison with manufacturing site. Let's say, for example, precast concrete, when you produce a precast concrete and send it to the construction site, the MRL is 20%. It means that only 20% is produced in the factory, and 8% it's doing with the drill and the hammer with the standard construction manufacturing on the construction site. We have MRL 80%. 20% is only assemblies. That's why we're doing all of that stuff: framing, windows, wires, pipes, precut pipes, and everything that related to the exact house, to the exact stage. And by the increasing this MRL, when you produce it you can control it. It's predictable, and that's why you reduce the price.
So are you making every component to the house then? So if I give you a floor, I'm giving you a house, I'm giving you a plan, you ingested it, you put it into your system, and then the factory just makes all the parts of the house?
Exactly. We put the plans in our software. The system automatically generates this 3D model of the house.
Okay.
Share it on 35 stages. After that, share it on task on quants, and automatically give the batch of task of manufacturer to the manufacturer what they need to produce and where we need to deliver it and how to assemble it stage by stage.
Why work on this?
Why I'm working
Why work
on
on this problem? Why work on this problem for you?
I can explain you one interesting story. I have heard one lecture from the professor from MIT, and he graduated in early 90s, and he explained that, well, I graduated MIT. All my classmates, they go to Google, to Microsoft, and so on. My father told me, well, you need to go to that industry where everybody is not so smart, because you will be the smartest guy in this industry. And he explained that he starts to sell wheels for chairs. And he explained, well, guys, I have right now more than 50% of all the global factories that produce wheels for chairs. Because I started, as a sales, but for me, it was very easy to grow. And that's why, because I was the smartest guy in the industry. Well, it's a funny story, but do you know why we choose this industry? Because it's the biggest industry in the world, one of them. And it's more conservative as possible. And that's why we understand that in this industry, our expertise can help and can change something. Because, my previous company, when I worked with a deep tech in Incata, and we helped deep tech startups to grow from idea to mass production, I saw one of the main mistakes from the deep tech, they don't understand the market. And because of the size of the market. Maybe the idea is very good, but the size of the market is very small. And that's why we choose, let's choose the industry that less, the more obsolete as possible and as bigger as possible. And we choose a construction to do that.
Got it. So how big's the team now?
We have roughly 200 folks.
200 folks. Gotcha. And, it's interesting, this you make this concept of kind of go to an area where other people aren't looking. I'm always intrigued by it. This is when there's a problem. I'm going to give you a little story because you'll appreciate this story. So obviously, as I mentioned, I'm originally from Michigan, and my mom recently moved back up to Michigan, and she moved into a community for older people, like an active elderly community, and they're all individual homes, and built by one of the don't even really remember the name of the home builder, but built by one of the big national home builders. Okay. Now, over the years, because my mom has moved actually a few times and I've helped her with that process, I've seen kind of the pricing, the quality of the housing in a few different geographies. And so this latest one, though, which was fascinating, they built the house, I walked into the house, okay? And I am telling you, I think the house cost somewhere around $500,000, okay? Maybe a little bit less, okay? The quality was a piece of shit. I was blown away. I was shocked at how bad it was. And I've seen a lot of construction over the years. I've been exposed to a lot of it. I understand costs are going up. But when I saw this, I'm like, this is a bad product. So when I see that, and I'm just like, that's what I get excited. Obviously very excited about what you guys are all doing. I'm two levels. One, it is a big problem. I think it's these big, large home builders that really dominate chunks of the market are just putting out a bad product. And then secondly, obviously we have a big affordable housing issue in the US. But yeah, so I thought you'd appreciate that.
Yeah. Do you know that there is a joke that I thought that American dream should look like a little bit different?
Well, it goes back, it's interesting, man. I'm because I spent a lot of time in Europe now. My wife's French. And it's interesting. And when I'm going back and forth, something I'm just seeing, which is just crazy, which is just
the level of quality is much more higher there. 100%.
Yeah, but it's not even just in housing.
I can
it's
explain you why.
Tell me.
I can explain you why. There is two reasons. The first of them, it's, let's say, for example, one guy is working on the construction And for example, like putting the bricks, he doing it 20 years and doing it bad. Do you know? Nothing changed 20 years,
Sure.
and he 20 years doing bad job. And there is no option for others because it's not a lot of people want to go to the construction. Not the smartest guy is going to work on the construction 100%. And based on that, anybody have a lot of option. And he's doing it bad. She's 20 years think that it's good, and nobody will not argue with him because he have no option in this case. And this situation is only in the United States, and it's because of the logistic problem. If, for example, can deliver houses from China or pay somehow, for example, for export or something like that, so somebody will build a house for us. Let's say, for example, I will pay money, and in one day, I will have a house that will be produced in China, delivered here, and assembled. If it will be possible, 100% in the United States, we will have the best houses. But it's impossible because it's a logistic problem, because you need to deliver a lot of different materials and assemble it at one time in one place.
Okay, that makes sense kind of to me. I need you to clarify one thing. What do you mean by the bricklayer who's been doing it for 20 years, bad, might not be doing it correctly, there's no one to replace him or her, but how is that a unique U.S. problem? I didn't understand that. I understand the logistics piece.
Yeah. Well, it's mean that why we have this explanation is why the quality is very big. It's not how the solving the problem, because there is no option, and there are a lot of construction workers who have no skills, and nobody will not tell them that they're doing it bad, because they have no option. The customer have no option. They have only one guy who's doing it, who put the layers bad, who's doing bad job, and you have no option because you have no house. You have no house with any quality.
But how is that unique to the U.S.? I'm not following that. Isn't that the situation everywhere?
Because in the United States there is a lot of option for the people to do another job, to be a lawyer, to be software engineers, or something like that.
Okay, gotcha. That's like you're saying it's kind of one of the negatives, I guess, negative side effects of having a more dynamic economy.
Exactly.
Okay, understood. Okay, so
maybe it's a very strange explanation.
No. It's interesting. I didn't think of that. Okay, so the idea is to build these kind of micro factories closer to where they're built. So how big is one of these things, and how many homes can it build per year, approximately?
Well, the production capacity of factory, it's a house per day. It's 2,500 square feet house, something like that. And it can produce a house per day, and its production capacity, but assembling time, it's roughly 35 shifts. It's 2 months, something like that. 4 guys assemble in 2 shifts in months and a half, one house, and that's why the factory working at the same time with 20 construction sites.
Okay. So the idea is it can work with kind of up to 20 construction sites. The factory at the same time can produce about 350-ish houses a year.
Yeah.
Or the parts to it, but then there's the actual.
Yeah. That's why the factory itself, it's a factory with machines, plus all the tools and the teams for 20 construction sites.
Got it. Okay, so you're originally from Belarus, and from my understanding, the majority of your engineering team is based there, correct?
Yeah.
So talk to me about, I guess, the good and bad of having, in your focus in the U.S. market. So kind of give me the good and bad of having a more geographically dispersed team, especially when you're building something physical.
Well, first of all, why we're doing it here in Belarus? Because Belarus was an assembling area of all USSR, and here we have a great gene pool of engineers. And for me, it's much easier to hire a big team here than in comparison with United States, because in the US I need to compare with some big corporations like Tesla or something like that, and for the startup to hire 100 engineers, it's impossible. I think that's why, and the cost of the project is 100% different. I think that the differences can be even 10 times, and this is why such kind of projects in the US will be difficult just even to do. Because, for example, I will have an idea. Let's say I'm a guy who's living in California, have a great background of engineer. I have an idea to do such kind of project like Cuby. In the beginning, we spent for the idea more than 100,000 man hours. In US, it costs roughly $50 million. I will come to the VC and tell them, guys, I have an idea for the pre-seed stage. Give me, please, $50 million. Well, they will tell like, yeah, well, no problem. We can do it easily. And that's why such big projects where you have tons of engineers hours and so on, based on the rating or level of engineers and so on, it's impossible to do it there. After that, when the company begin to generate the profit, when they have factories and so on, for sure it's easy. The R&D cost is not so big in comparison with the revenue that the company has.
Yeah,
Why,
so cost.
when the mask is doing the project, let's say, for example, they do the Starship or maybe something like that. Everybody know him, and that's why he can generate any amount of money in the pre-seed stage.
Understood. Okay, so cost is obviously a big benefit, and you're from there originally, obviously, which is
plus access to the engineers and to the labor. Yeah.
How
bad stuff for sure. Also, there is some kind of bad stuff. Like we have some small team in the United States for sure, just to compare our design with the US codes, with doing some local engineering and so on. And for sure, there is some kind of misunderstanding in dialogue and discussion. For sure, there is some difference between the metric system and the US system. It's a meter and foot, something like that. But it's everything. It's
okay. So one of the things I wanted to talk to you about. Obviously, I'm sure you've seen the horrible fires in Southern California. And I was listening to some interviews and podcasts, and I was like shocked to learn. They were talking about how like just very few homes in the Pacific Palisades actually survived the fires. And then it got into like talking about construction, and obviously largely in the US, everything now for cost reasons is what we call stick built or, wood framed, especially these kind of mass produced homes. And then there's this, I read this very interesting article, like the whole trend of like the last 15, 20 years in the US around like multifamily development is this like, it's the same product. It's like a 4 or 5 story building, whatever the max you're allowed to go up with stick built. And it's like, it's just like all very vanilla if you start looking at it, but then like they're built everywhere. And so it's like kind of the same product over and over again, but it's this, like I said, going back to the quality is just crap and it just doesn't last. And so how do you guys, first question are your homes like wood framed or what we call stick built, or can you just talk to me a little bit about the underlying quality of the structure?
No, we use a steel frame and we use the panels. And one of our philosophy is that we need to use materials that you shouldn't maintain during 10 or 12, 15 years. That's why, we have more stable and much better quality house, because we produce also all the parts on the factory. And why we're not using wood? The wood as a material is very complicated to make very high accuracy in milling or in processing. Okay. When we produce the steel parts, we can do 0.5 millimeter accuracy. And when we can do that, it's easy to assemble it on the construction site. When we can do the same parts from the wood, based on the temperature, moisture, or something like that, it can change its shape. And when we'll assemble it, we will not use unskilled labor to assemble it, because you need to mill it, you need to drill it, or something like that, just to assemble it.
That's very counterintuitive, right? You would think the opposite.
Yeah.
Like just because of what everyone uses, and it just, separate conversation, comes down to cost, obviously. So if you're looking at, from what you've seen, you're looking at a home that's a $500,000 new home, okay? Mm-hmm. How do you think about breaking down, like what percentage of that is materials, labor, land costs, kind of general roundabout?
Well, I roughly explain you the mathematic, how the Cuby is working. In the United States, roughly 30% of the cost, it's cost of material, plus 70% it's a cost of labor, plus subcontractors that you use to assemble the house, roughly. Okay. It's very roughly. In Europe, it's 50-50, 50% cost of material, 50% cost of labor plus subcontractors. Okay. It's a standard operation in lean manufacturing. When I create the conveyor belt, we reduce labor and subcontractor part roughly 10 times. That's why we reduce the self-cost using almost the same materials and same processes. And that's why we explain to everybody that Cuby, it's a standard construction, standard technologies that already exist in the market, but we produce it in an absolutely different way. That's why Cuby reduced 70%, roughly 10 times, by reduction time, back and forth. Plus, we're taking almost everything from the subcontractor. The Cuby produce itself, glass panes, doors, panels, tubes, and so on. We're not using any subcontractor. We use only raw material in the beginning and taking all of the profit inside the factory.
Where do you, when you think about kind of projecting out in 10 years from now?
We have a goal.
Yeah, give us the goal.
We have a goal roughly to have in 10, 15 years, 200 factories in the United States. And in this case, with our production capacity, we will cover only 0.5% of the market.
All right, so I want to,
it's an ambitious goal, 0.5% of the market.
I mean, it is wild. One of the things I've got such an appreciation for during my, the work that I did in Detroit is really how localized real estate markets are. Exactly. That is the point, right? That is the point. It's like, it's such a massive industry. It's just like, it touches everything. It's very foundational to our lives. And so, yeah, no, I get that. So it doesn't surprise me you're saying you're spinning up a couple hundred factories and it's like 0.5% or a couple percent. Okay, let's dig into, which is one of the main themes here, which I feel very strongly about, is decentralized production. So when you were thinking about, I guess, distribution, as you're saying, you have to think about distribution upfront, which most deep tech companies don't think about, and kind of re-engineering the home building process. Was the idea to always do decentralized production, or is it just like, hey, this actually just makes way more business sense, or from a dollars and cents standpoint, to do it this way?
One of the main stuff why we're doing the mobile microfactory, there is 2 reasons, even 3 reasons. The first of them, it's erection time. It means that if you have all the machines and you have a warehouse, you will find warehouse somewhere. It will take you roughly 8 months just to put all of the machines and start mass manufacturing. It's called the erection time of the factory. In our case, we produce everything in the ship containers, and these containers already house, a building for these machines. And we produce it in China, deliver it, and erect the house just on the soil. The house of the factory, the building of the factory. This is, reason number 1.
And the reaction time is, how do you think about the reaction time?
1 month.
Okay.
That's why we reduce it. And the second reason, here in Europe, we have a lot of experience to produce precast concrete factories. And after 15, 20 years of working there, they built everything around it, and they have no factories, they have no market, they have no customers, because it's very complicated to deliver very big, and heavy parts more than 150 kilometers. If you will deliver it more than 150 kilometers, for you, it's not make sense to produce it. That's why a lot of them have no business based on that. That's why your factory should remove to somewhere if you will build everything around it.
I guess, so if there's like low value density, so it's very expensive to ship, is kind of what you're getting at.
Exactly.
Okay. Got it.
And the second stuff is local material suppliers. As I told you, that construction is everything related logistic. And if you will have a problem with supply some small part, let's say some trim or maybe some door, it will stop all the conveyors. That's why you need to use only widely used materials that you can buy in standard shop, in the Home Depot, or for the local supplier. And if your supply chain will have some problem with the ships, with any stuff of that, you can continue producing houses and earning money. That's why when you have a big decentralized factory, for you it will be the problem to deliver. Okay, all of that stuff that I explained to you now. This is why we're doing modular, doing mobile microfactories.
So the idea, so when you think about the engineering and the machines that you've built to build all the components to the house, what you're getting at, just to make sure I'm clear, is you use pretty much all off the shelf materials. It's all
goal.
off the the goal, of course.
It's a goal. Only use the widely used materials that we can buy in the market.
So it's really more of a question of how do you build the system to integrate and build the parts out of the components, essentially, or build the components out of the parts.
Yeah, and do you know that it's looked like our design engineering of the kit of parts is look like when you put the saddle, put it on the motorcycle. Do you know?
Sure.
Because we need to use old materials that is widely used everywhere, and we need to put them into the high level engineering and very high precision, manufacturing. This is a challenge that we are, doing and have every day.
Got it. Okay, so you talked about the first being kind of this low value. If you have heavy low value products, it's really important to be closer to where it's located, to where that thing is being used. Of course, otherwise
you need to be as close as possible to the warehouse where the materials is, and you need to be as close as possible to the place where you need to install it. Yep. This is the main rule.
And where's that? And you found, because that's an interesting one, right? Because in everyone's like, utopia, it's like, well, that's how everything used to be, which is a separate conversation, which is hopefully technology can enable this, which is like you actually have really, truly much more localized production in manufacturing. But there's this balance, right? Because you're fighting up against companies with a ton of scale, a ton of economies, right? So how did you guys think about balancing, like from an economics and market standpoint, size, location and size?
Do you mean that? Well, that's why that size of the factory, by our point of view, is that it is exactly, the balance between them.
The balance. Okay.
Yeah.
That's what the question was. It's like, of course, utopians, like every town should have a factory building houses, right? But it's like at some point, like you need a certain amount of scale to compete. Otherwise, you want to keep.
You need to have a demand. You need to have a demand, because do you know that house per day, it's not a lot, but it's not small, demand.
Sure.
Because, in a year, one factory built this small city in 300 houses.
Yeah, for sure. And so is the idea these factories, can you pick them up and move them? Or is the idea that
it can relocate? But, it's possible to move it, but I think that, well, they will relocate it maybe occasionally, maybe one or two of them will relocate.
Yeah, not often.
Yeah.
So where are you guys at now? Where are you at with the factories and kind of in the development process?
Yeah, we have a contract. We are building the factory in Cyprus and in Las Vegas.
Okay, so 2 factories.
Yeah, this is our goal for this year, for these 2 years, to build these 2 factories. We have one now. We need to build 2 to test the process in comparison with US codes and so on. And after that, we need to scale roughly to 8 to 20 factories a year. That's why we have a Papa factory in China now that produce machines and something like that. We also accelerate activity also in China to accelerate production capacity for the Papa factories that produce factories.
I gotcha. Okay, so largely your supply chain for building the factory and the machines is in China.
Yeah.
You're building all the design and the engineering and the software, as we discussed at the beginning. That's all being done with a team largely over in Belarus, correct?
Yeah, exactly.
And then the whole idea is you bring all those pieces together and you're deploying factories in in Cyprus and in the US, but the focus being the US market. Let's talk about actually building the houses, because that actually comes down to distribution, which is the critical piece. So is Cuby actually going out and buying the land and building the actual houses and selling them?
Right now, our business model is we are partnering with the local developers and with local big GCs, but I think that mainly developers. And with them, we open in the factory and we have an offtake from them just to build all the output of the factories that we'll have.
Gotcha. So you'll be, like, the idea is working with, a small group, or maybe a
small
few,
or big groups, that have a land, that are developers, that know what kind of the building the people need in this area. They can solve all the problem with the government, with the townships, and so
Okay.
on. And our part of the job is to build.
Got it. So in that way, do you look at yourself as are you the construction company then? Is that kind of how you think about it? If you were to compare it with the traditional way of doing it today?
I think that we're more technology and manufacturing companies.
Okay.
Because
right, because you're still going to
we don't like to call it construction, because construction, it's a different process, as I told you, where there is a project manager.
Yeah.
In our case, a conveyor. We are more technology manufacturing company, and we manufacture assembled house.
I get it. And from your estimate, when you think about delivering this steel framed, higher quality home, what are you kind of estimating from a cost standpoint and the cost reductions we discussed, like the ability to kind of deliver, I guess you normally go on a per square footage basis, but the idea is to deliver higher quality product at a better price, right?
Roughly, the European quality houses, we will supply as a self-cost. It's a self-cost of the factory. It's roughly $100 a foot, something like that.
Okay, that's what cost you.
It's a fully cost for us, starting from the horizontal work and ending for the interior and exterior finishes plus kitchen.
Okay, got it. And then how does that come?
The selling price, I think that will be determined based on the region, because you know that we easy calculate it in the software. We put the cost of the local material and the cost of salary in the system, recalculate the cost of the square foot.
And how from your estimates, how does that compare with the traditional way that's done to get to that same point? If you're a small, medium-sized home builder building something, what is it costing you per square foot?
I think that they have starting from $160, $170 to $200 a foot, something like that. It's a mathematic, as I told you, to reduce 10 times the 70%. That's why we are roughly 40% less cost Cuby than the traditional construction.
Okay, so there's been several companies trying to attack this problem.
Sure. The market is big.
Market's very big. Everything from, just pure construction technology to help make construction companies more efficient to, like you said, folks actually doing, as we discussed, you talked about the two different types of modular housing. And no one really seems to have cracked that code, especially the labor problem, which I know, which we discussed is a big piece of the strategy. But if you were to boil it down, is there kind of one main reason why you don't see anyone's been able to crack the code to date? Was it with their approach, just the timing wasn't right?
Do you know why? Because it's very complicated. That company will be the winner who will spend as more engineering hours as possible there. That's why nobody will spend in that area more engineering hours that we spend now.
Okay.
And this is it's a numbers game. We need roughly plus maybe 300 or 400,000 man hours just to polish the process. And it's also a lot. But
it's a lot.
It's a lot. Yeah. But
what is that? What's 400,000 man hours? How many people is that per year? I'm doing that. I'm doing that math. Hold on one second.
Yeah, it's roughly 200 people will work roughly for 3 years.
Okay. Wait, I'm doing the math. Hold on.
Yeah.
400,000. Let's just say we'll use 8 hours a day.
Yeah, it's
right?
160 hours a month.
No, it's more than that. Hold on. 400,000. About 8 hours. So it's 50,000 hours a day divided by 200 people, you said? 250.
250. But it's for, there is in development, there is a process. It's called technological readiness level. It's TRL. Yep. There is 9 TRL. We are right now in between TRL 8 and TRL 9. That's why we're starting this first to factory and polish the process and technology. And after that, it's scaling process. And after the scaling process, we will need 3 or 4 factories to do that. And after that, we can scale very fast.
So you really look at this whole thing, if we were to boil it down, which is, it's really an engineering problem. It's kind of how you think about it.
Only.
Engineering
and manufacturing. But it's the same engineering.
Sure. One of the things that I'm switching over here now back to kind of the local economies, decentralized production theme. But one of the things that I didn't have an appreciation for until I really started digging into it was how actually the majority of the market are actually small, medium-sized home builders. I think I heard a number. Is it something like 70 or 80%? Is that right?
Yeah, something like that, even more.
Yeah, it's fascinating because you almost feel like it's just dominated by these large, very vanilla developments from large home builders, but it actually, in fact, like it's actually a long tail problem, right? How do you get into these local markets? Which is like what I'm just super jazzed about is how do we really unleash kind of real economy, long tail entrepreneurship, which I think is kind of the ambition of Cuby if executed on. I mean, it's what it results in, which is pretty cool.
Yeah, I think that the same stuff was Uber, because there are a lot of taxi services in each region, in each country, in each cities. But when they come up the idea how to scale, they just come into any market and take the majority of the market.
Right, it's tweaked according to the local conditions and
Exactly.
how the local
the company
different
who will
business.
the company who will find the key for the scaling will be the winner.
Okay, so I have a in one of the conversations I was having with another investor of Cuby, he made a comment about you, and he a wonderful comment, and I want to dig into it because I think it gets to your point about the engineering problem. And he's like, how I would describe Oleg? I would describe him as an engineer's engineer.
Yeah.
So
talk to
me how your brain works.
Well,
when
I don't know,
because that's what that and he's an engineer and loves engineers, and so he's an engineer's engineer. So I wanted to dig into that because I think it's really important, representative of like how you think about the world as an engineer and with what you guys are doing. Because I think sharing that knowledge, we need more engineers working on hard problems. So I think it's really important.
I can try to explain my approach.
Sure.
First of all, I'm a physicist, and only after that, I'm an engineer.
Okay.
And I have very interesting approach. I try to find in any business, economic, or something surround me, I try to find physics analogs. And if I find physics analogs, I can predict what's going on. Let's say, for example, this company behave itself as a water near zero. I can try to find the analogs, and if I will find it, I can predict what's going on with this company in future.
I didn't understand that. Can you repeat that? What do you mean by analog?
Okay.
And yeah, go step back.
Let's say, for example, there is a physical processes.
Okay.
Let's say, for example, melting of water.
Mm-hmm.
And this process there is exact description in physics, what's going on next minute, after next minute, and so on.
Mm-hmm.
And there is some areas or there is some features or something like that behave its process. I try to find the same criteria for the companies, for the people, or something like that. And if I find and to compare it, and I can say that this guy is in this situation behave himself, let's say, as a melting water, I can think and predict what this guy will do next 2 or 3 minutes after that. And I can explain you why it's working, because all of our psychology and business economics is based on the physics rules. If something will happen, let's say with the gravity, all the economy, all the business will change in 1 day or in 1 second. Or if we will change the physical rules, we will change all the society, all the behavior between the people and so on. That's why it's a base. And if you will try to find the physics base with the people, with economics and so on, you can predict how it can behave itself.
Interesting. So you kind of
this is how I'm thinking.
Okay. Interesting. Yeah. So you look at the physics, which makes sense, right? Which is obviously driving human behavior and driving the next action, then to the next action, and the next action.
In not only the people behavior, company behavior,
sure,
business behavior, or something like that.
And how does that apply? How does that thinking apply with like how you approach, how you're approaching Cuby?
Well, let's say I wrote a book. It's called The Human Vector. And roughly 6 years ago, we find that any employee can behave itself as a vector, where the lens of the vector, it's his personal skills, how good professional he is. And the angle, this is his life philosophy and the principles. And that's why the effectiveness of the team, this is just the total vector sum of all its employees. That's why we take the vector algebra book and have exact rules, how to fire people, how to hire, how to fire, how to work with them, and so on, and begin to use it as a mathematical approach to govern the people. This is one of our approach, how I think regarding the stuff of physics and the behavior in the people. That's why we use, for example, the same methodology in Cuby for sure.
Interesting. So so you look at kind of the team members as, you look at them as they each have their own vector, and those vectors have to work together.
Exactly.
That's why, whatever methodology you have.
Yeah, that's why.
Interesting. Cool. Well, I think that I think it's a good place to wrap it up, man. I think I'm obviously biased a little bit, but I think that, and we didn't even get into so many other topics around labor and all these other things, but hopefully we'll have you on again, and we'll dig into that. Tell everyone where they can reach you, or where to be reached online, or any information either for yourself or for Cuby, and we'll put a link in the notes.
Yeah, well, you can easily reach me. My mail, @CubyTechnologies.com.
Great. And any social handles or anything, or no? Just you're a straight email guy.
Yeah. I have a LinkedIn. I have a Facebook. Okay. No problem. Cool. I will be glad to answer any questions there.
Great. All right. Well, thanks, Oleg. Appreciate the time.
Thank you, Jordan. Talk to you soon. See you.